Hi everyone. Today I am going to solve previous year questions in potentiometer. If you want clarity in theory, you can go through the link that I provided in the description. Let us see first question. A potentiometer wire AB having length L and resistance 12R is joined to a cell D of EMF E and internal resistance R. Yeah, in this he is giving main circuit. In this he is giving main circuit. Yeah, parameters. So that is the thing. Yeah, he gave length of the wire, so that is LAB is L, and he is giving resistance of the wire AB, that is 12R. Right. Let us see next. SLC, of course, he also gave cell D of EMF E and internal resistance R. So these are nothing but main circuit cell EMF and internal resistance. That is the thing. Yeah. Right. A cell C having EMF E by 2 and internal resistance 3R is connected. Where it is connected? In the sub-circuit it is connected. That also we can see. Its cell EMF is E by 2, 3R. Okay. The length AJ at which the galvanometer as shown in the figure shows no deflection. Okay. He is asking us to find this AJ, length LAJ, at which galvanometer shows zero deflection. Right. Yeah, here you can see he gave main circuit parameters, sub-circuit parameters. He is asking us to find the LAJ, length at which galvanometer shows zero deflection. Right. What is the working principle of potentiometer? When the galvanometer shows zero deflection, the sub-circuit cell EMF becomes equal to potential difference between junction and moving contact position J. That is the thing. Right. So that means, so when the galvanometer shows zero deflection, sub-circuit EMF, cell EMF becomes equal to VAJ. So that is E by 2 becomes equal to VAJ. Let us say I0 is the current flowing through the main circuit. Right. So from Ohm's law, VAJ becomes equal to V is equal to I0 into RAJ, where I0 is the main circuit current, RAJ is the resistance of the wire between A and J. So that is the thing. Right. Let me make it as equation 1. In order to obtain this I0 current, we need to apply KVL to the main circuit. Yeah. So let me draw the electrical equivalent circuit of the main circuit. Yeah. Here we know the main circuit cell EMF, its internal resistance R, and wire AB resistance, that is 12R. We already assumed the current flowing through the main circuit as I0. Right. We know that current always flows from higher potential to lower potential. Therefore, we indicate positive sign and negative sign in the direction of current flow. So when we apply KVL, what we are going to get? E minus I0 12R minus I0 R is equal to 0. So that is the thing. E is equal to what we are going to get? I0 into 13R. So I0 becomes equal to E by 13R. So let me take it as equation 2. So when we substitute into equation 1, what we are going to get? E by 2 is equal to E by 13R into RAJ. So we are going to get RAJ is equal to 13R by 2. Let me move to next slide. So RAJ is equal to 13R by 2. So this is the thing. But we know what is RAB. So RAB is 12R. Yeah. Resistance of the wire between A and B. So this is 12R. When we take ratio, what we are going to get? RAJ by RAB is equal to, right. So 13R by, so 2 into 12R, that is 13 by 24. But we know that resistance of the wire is given by R is equal to rho L by A. That means RAJ, resistance of the wire between A and J, is going to be rho into LAJ. LAJ is length of the wire between A and J. Similarly, RAB is equal to resistance of the wire between A and B. That is going to be rho LAB by A. What is LAB? Length of the wire between A and B. So that also we know. What is that? That is L. Yeah. Right. So it is going to become rho L by A. So when we substitute into the equation, so right, what we are going to get? this equation. RAG is equal to rho LAJ by A. RAB is rho L by A. Yeah. So this is equal to 13 by 24 from above equation. So that means LAJ is equal to 13 by 24. This L goes this side into L. So this is the answer, LAJ. Right. So which option satisfies? Let us see. So option C is satisfied. This is the answer. Let us move to next question. Yeah. Here what he gave, let us see. The resistance of the meter bridge AB in given figure is 4 ohm. Right. Meter bridge means length of the wire AB is 1 meter. That is the thing. Right. What is RAB? He gave 4 ohm. With a cell of EMF E is equal to 0.5 volts and rheostat resistance RH is equal to 2 ohm, the null point is obtained at some point J. So that is the thing. Right. So when E is equal to 0.5 volts, resistance is 2 ohm. Right. Then null point is obtained at J here. Yeah. When the cell is replaced by another cell of second case, this is. So let us say this is first case. In the second case, cell is replaced by E2. Yeah, the same null point J is found for RH is equal to 6. Now for the second case, rheostat resistance is 6 ohm. For that case, same position, means both are coinciding. He is asking us to find E2, cell EMF. Right, let us see. Here we have to notice that here what is that? Potentiometer experiment is performed 2 times. Because for the cell of EMF 0.5 volts, what is called null point is obtained. Cell of EMF E2, null point is obtained. 2 times it is performed. What is the working principle of potentiometer? When the galvanometer shows zero deflection, cell EMF becomes equal to potential difference between junction and moving contact position J. So that means E becomes equal to VAJ. That is the working principle of potentiometer, right? Yeah, let us say I0 is the current flowing through the main circuit for the first case. From Ohm's law, this becomes equal to I0 into RAJ. That is the thing. Let me take it as equation 1. Yeah. So in order to obtain main circuit current I0, we have to apply KVL. Okay, let me draw the electrical equivalent circuit of the main circuit. So in the main circuit, which are connected in series? Yeah, battery voltage 6 volts he gave, and wire AB resistance. What is that? 4 ohm. And rheostat resistance for the first case. This for the first case, I am obtaining current, that is I0. Yeah. So we know that current always flows from higher potential to lower potential. In the direction of current, we indicate positive and negative sign. When we apply KVL, what we are going to indicate? 6 minus I04 minus I02 is equal to 0. So 6 is equal to 4 plus 2, 6 here. So that means I0 is equal to 1 ampere. So let me take it as equation 2. Yeah. So let us apply. Let us consider second case. Let us say I0 dash is the current flowing through the main circuit for the second case. Okay. Right. Okay. So we taken like this now. Yeah. So let me consider electrical equivalent of main circuit. In this battery, wire AB, yeah, and rheostat resistance. Okay. So right, rheostat resistance. How much for the second case? We know. How much? 6 ohm. Right. So this is 6 volts. This is 4 ohm. We know. So we already assume I0 dash is the current. Current always flows from higher potential to lower potential. So when we apply KVL, what we are going to get? 6 minus I0 dash into 4 minus I0 dash into 6 is equal to 0. 4 plus 6, 10. 6 is equal to what we are going to get? 10 I0 dash. So that means I0 dash value is 6 by 10. Right. Let me take this as equation. Already we have taken 2 equations, 3. So let us apply potentiometer working principle to second case. Now what happens? E2 becomes equal to, let us say, VAJ dash. So from Ohm's law, VAJ dash becomes equal to I0 dash into RAJ. So that is the thing. Let me take it as equation 4. So when we consider equation 1 and 4, what we are going to get? Yeah, when we take ratio of these two, 4 by 1, they are similar. So E2 by is equal to I naught dash by into RAJ, I naught dash into RAJ by I naught into RAJ. As a null point is coinciding, RAJ is same. Resistance of the wire between A and J is same. J is coinciding. So they can be cancelled. So now E to E becomes what? E into, yeah, I naught dash into I naught. So we know what is the E value. We can see 0.5. And I naught also 1 ampere. We can take those. So 0.5, I naught dash is 6 by 10. I naught is 1. So what we are going to get? 5.5 nothing but it can be written as 5 by 10. So we are going to get 30 by 100. So 3 by 10, 0.3 volts. So E2 answer is nothing but 0.3 volts. Yeah. Which option satisfies? Option B is satisfying. So this is the answer. Yeah. Today I have solved 2 previous years questions. That is it. Thank you.